welcome everyone. I'm Emily Bembenek. I lead the Center for Applied AI here at Chicago Booth under the leadership of Sendhil Mullainathan, whom I'll introduce in a moment. The center, just to give you a sense of what we do, if you're new to our work, we support a variety of research projects and applied AI projects that focus on how AI can improve human lives and augment human decision making through policy, tools, and raw research. Over the past year, we've been working on an algorithmic bias initiative, which is primarily focused on bias in healthcare, where we work with governmental and commercial organizations, healthcare institutions, and commercial entities to help them identify and then mitigate the bias that arises in their systems. So today I'm really excited to have a panel to talk about bias in AI at a high level and hear about how they've been encountering and addressing issues like this in their own fields. And I'm excited to learn from them today. I'm going to introduce you to Sendhil. Sendhil Mullainathan is our faculty director here at the center. He's the Roman University Professor of Computation and Behavioral Science here at Chicago Booth. He's a literal genius, and he's written some fantastic work on algorithms in healthcare, poverty, discrimination, etc. And I'm really excited to have him introduce everyone today.
Thanks, Emily. And thanks to everyone who's joining to listen in, and especially to the panelists. I'm super excited for this conversation because algorithmic bias is a topic that I think is particularly important. You might have heard a lot about it, but I think despite the level of discussion, it's something that merits even more discussion. So I'm really eager to hear what the panelists have to say. Let me just give quick introductions to everybody. Amy Strader has a really interesting career. She lived through the AI winter in the 1990s at NASA, of all places. And at that point, when AI interest was drying up, she moved to Booth, did a degree here, and then for the past 15 years has been working at Microsoft, where she's had a front row seat for seeing all of this stuff developing. Ben has the misfortune of having been a student of mine, but somehow he managed to survive that and actually thrive despite that, and is currently Director of Product Marketing at HTO.ai, and has actually written a book, which I hope you'll have a look at, published by O'Reilly Media just a few months ago. So this is pretty exciting. Amy Shea heads partnerships at TensorFlow at Google. And previous to Google, she's worked at Nest and Time Warner Cable, and she also graduated from Booth in 2013. Andrew, who's not with us, so I think I won't introduce him, Emily, should I? I'm probably not worth it. Okay.
I'd wait until, if he comes in, then
if he comes in, I can join. And finally, Chen Hao, who I've known for quite some time, is currently at UC Boulder as a faculty member, but will actually be joining us in the CS department at Chicago very soon. And I was very, very happy to recruit him. He's worked on a variety of topics, largely in natural language processing, and has numerous distinctions as an academic, including an NSF Career Award. So I will hand it over to you, and I'm looking forward to discussion.
Oh, I guess are we just starting right away? Are there any warm-up that we should do? Okay, yes. Cool, great. Thanks, Sendhil, for the introduction. And Sendhil has told us a lot about the past work that the panelists have done. Let's start by just sharing what you're working on now and how AI is impacting your industry as of now, I guess. Why not start with Amy? And we have two Amy's, I guess. Amy Strader.
Okay, I'll go ahead and start. Right now I work at Microsoft. I'm in the sales organization at Microsoft, and my current interest is understanding how we can improve the efficiency of our sellers overall, sort of reinventing our sales process, specifically of our cloud products at Microsoft. to improve the cost of sale, but also increase our customer satisfaction. So when I think about the impact of AI on what I do, there's really two places. There's us sort of eating our own dog food, as we say at Microsoft, using our AI technology to improve the efficiency of what our sellers do every day. And then obviously there's the conversations that our sellers have with the customers at Microsoft who are using our technologies to implement AI within their own businesses.
And
So, yep, Amy, I'm sure you can go next.
Sure, yeah. Thank you all for having me. This is such an amazing time, I think, to be talking about this issue. Google Research, I think, is one of the pioneering departments that has really helmed AI. I look after the partnerships related to TensorFlow, which was open sourced 5 years ago, right? And so we had a bunch of engineers and distinguished scientists at Google Research, including Jeff Dean, who were helming that effort. And the interest in open sourcing was important for Google for a number of measures, right? So first of all, internally, we apply machine learning to a number of different areas within all of our different apps. So for example, if you use Gmail, you might notice some really nifty like autofill completion suggestions now, right? Depending on what you want to write. That's been really fun. Google Cloud is really leveraging AI in terms of a number of different kind of diagnostic areas. For example, I believe they just announced several healthcare tools that enable basically discerning and capturing loose text and be able to interpret what that loose text string might imply for a diagnosis. And so you can kind of see how AI is really just front and center to Google. We've always wanted to be an AI first company, and open sourcing TensorFlow is really part of that mission. We wanted to democratize and open the toolkit for other practitioners, everyone from researchers all the way to hobbyists who want to play in this field. And it's very much the ecosystem approach with which I look after TensorFlow. And we are trying to both seed the market in terms of building partnerships with Microsoft and H2O.ai, but then also ensure that internally we're using the best of Google AI to power some of our products and services.
Great, that's a very nice overview. What about you, Ben?
Yeah, so you used a great word, and that's democratize. Like my company's motto is democratize AI, and I think so. My title is Director of Product Marketing, but a lot of what I do at H2O is around our machine learning interpretability suite, which is essentially our toolkit for explainable AI, and that holds a lot of the kind of post hoc analysis tools like a data scientist would use to kind of debug or do discrimination testing or fairness testing or explainable AI features. And so a lot of what I end up doing, as Sendhil mentioned, one was writing a book, right? So we have our post hoc analysis methods, but our view on kind of bias and fairness in AI is that it's a much bigger picture, and that there's this whole supply chain of data science, workflow, and post hoc review for discrimination or disparity is just one thing. So a lot of what I spent time on is writing this book, and it's around the people, process, and technologies that go into defining like a more fair AI ecosystem. And that starts from the minute you start collecting or creating data all the way to model monitoring and review. So we have one book that's machine learning interpretability that's specifically around what we think are the best methods for debugging or reviewing a model. But then we also have this book, which is around how do you build that team? How do you structure the projects? How do you design that workflow? And how do you build the technology that can appropriately nest all of these tasks in order to make better decisions as a data science unit? And then it starts to think about like the economics of the larger, like who's impacted, what are the externalities, what are the network effects of your machine learning decisions, right? So that's a lot of what I spend time thinking about, writing about, and kind of doing product strategy to kind of encapsulate that.
Great, that's a very nice segue. You're certainly getting ahead of the theme here. The next question that is exactly kind of going a little bit back, and just can you talk a little bit about what algorithmic bias looks like in your field? And that is the theme today, and I'm sure a lot of audience are interested in learning more about what you are seeing in practice. And Andrew is joining, I guess. Sendhil can maybe give quick introduction. I guess not. So let's go back, and this time let's start with Ben. And I guess Ben was already getting ahead and trying to solve the fairness issue.
Sure. So what does fairness look like is a really tough thing, right? We just put out a paper that we partnered with BLDS, which the director of AI Fairness is also Booth alum, Nicholas Schmidt, and then Discover Financial, because one area, I have a finance background, and one area that I'm particularly passionate about is fair lending, right? We talk about the decisions that AI systems make, and not enough conversation goes into what are the externalities and the impacts of that, right? And I think access to capital and lending is super, super important, and it gets kind of a bad rap because the idea is just, oh, you know, a credit card, who's going to get it, who's not. But I would assert that disparity in access to capital has created waves of impact and GDP loss over decades and societal problems. That aside, what we spent time doing is sort of defining what is fairness, right? And the things that we use are sort of disparate impact analysis, where there's a couple of metrics like, you know, marginal equality, SMD, and you start to look at with one category of a group, whether it's ethnicity, gender, age, is it being treated disparately? And are we seeing like more false positives or more false negatives within that class? Right. So that's kind of how we look at fairness and just, you know, disparity or discrimination at H2O. I should caveat that by saying, like, one, I'm not a lawyer, and two, I'm not an ethicist. So we try to tread this very lightly and not assume that by giving you access to disparate impact, you know, modeling methods, we're not saying, okay, your AI system is good to go, right? This is just one piece in a much larger, like, puzzle of solving, does this machine learning system even make sense? So that's where we're starting. And we think it's a good place to start. And one of the things we were talking about before everybody jumped on is that our hopes with this paper with Discover and BLDS is that we sort of get this kind of summit or symposium where people say, okay, we agree that this is a definition of fairness, because a lot of times you'll see in finance, well, there's no defined definition, so we're not going to even, you know, we're not going to touch that yet. So it has to start with everybody kind of getting in a room and agreeing this is what disparity looks like in a machine learning decision or not. So that's where we started.
Yeah, I mean, I think what you said is very true. There's no definition of fairness that will fit all situations, right? So, I mean, part of it is what's fair in the context of the problem you're trying to solve and the audience that you're trying to serve. And then, I mean, you know, fairness it's a concept that philosophers have struggled with for hundreds of years, right? So to say that we're going to have a fairness algorithm that we can apply to the work that we're doing is, you know, a bit ambitious or maybe egotistical of us to say, right? So I think, you know, the way that we look at it at Microsoft is that we want to minimize any harm that could be done by bias that's in a system, right? And so that takes into account the audience, you know, as well as what you're trying to accomplish. But it's you know, it's impossible to minimize bias on every dimension, right? You know, it's a difficult problem. So we look at it in terms of, like you were just saying, where's the harm? Who are the audiences that we're serving?
I think
Yeah.
Andrew has joined us, so I
Oh,
just
I
wanted
guess-
to take a second, to welcome him to the conversation. Sendel, do you want to take a second to
Yeah.
maybe introduce him?
Yeah, it was when you asked earlier, Chen, how I didn't have my notes, so I pulled back my notes up. Andrew Zaldivar. Sorry, I'm sure I'm saying your name incorrectly, Andrew. Andrew Zaldivar.
No, you got it.
I got it. Oh, okay. Now next you have to say my name. That's the deal. No. Andrew is a senior development relations engineer for the ethical AI team, and so he's going to be ideally suited for this conversation. I'm really glad you could join us, Andrew.
Thank you very much, and sorry for the hiccups here. I am experiencing a power outage, but I suppose this will do for now. Thanks again, and I appreciate everyone's patience.
Thank you for joining. It's great to have you. I guess like the question we're at right now is we're trying to look at what algorithmic bias looks like in practice in your field. or in your industry. And what we discussed a little bit briefly before was what you are working on right now. So maybe I'll let Amy go on. Amy should go on with the current question, and then you can jump in and tell us what you are working on and how algorithmic bias might look like in your industry.
Sure.
Okay. Cool.
Cool. Oh, you can go ahead.
You can go ahead, Andrew, please.
Andrew, go ahead then.
Okay. My apologies. So I'm dialing in by phone, not by Zoom, so I can't see everyone's, the little green box that indicates that they're talking. So if I rudely interjected someone, I'm happy to put my mic on mute for a moment and then.
No worries. Just go ahead and tell us what you are working on and how algorithmic bias might look like in your industry.
Okay. So I caught the tail end of the last person whom I don't know because I can't see talk about or describe notions of fairness and some of the challenges there, and the same applies in my domain. One thing that I will add to that is I also think that part of that challenge comes from sort of just the current state of how AI and data technologies in general is being educated to the soon-to-be practitioners and what have you. And so there's a lot of knowledge gap that needs to be closed between those that have been studying and investigating and pushing, not pushing, but rather identifying guidances around, trying to best navigate this really challenging aspect of like, how does one define fairness? And then how does one even go about identifying notions of unfairness in either their data or in their trained algorithm. And so that's the role that I play is I try and sit in between the larger communities and the various research and product teams at Google that are tackling on these challenges and are creating these tools, these resources, publishing papers, and then going one step further and to responsibly democratize all these new technologies, all these new guidances to the broader, larger community in order for all of us to collectively help AI evolve ethically over time. Now, the other part of the question as to what I'm focusing on recently, I've been involved in some of the transparency efforts that's going on at Google. I happen to be one of the co-authors on this paper, model cards, which have since been turned into a resource that is available in TensorFlow. And also many other institutions, organizations, companies outside of Google have adopted model cards. And basically what the way that I would describe it is think of it as a boundary object, just an artifact that can help teams, groups, etc., understand the contextual nuance of the technology that they're building, whether it's the actual model itself or the data that's accompanying the model. Either way, a lot of these problems with regards to harm and the amplifications of these very problematic systemic biases that exist in algorithms, a lot of that stems from the lack of context that's being that was used in order to create the data, in order to create the model, and then those data sets, those models then get used in contexts for which they're just not well suited. And so we realize that the way in which practitioners, non-practitioners, technologists, non-technologists, because everyone's involved in the process. It's not just a sole engineer. We're talking teams and even those that are impacted by the outcomes of these algorithms should be able to participate. And yet there's nothing that exists in order for them to be able to participate. So we're hoping that the transparency effort here by way of model cards and similar efforts that are going on will again, as I said earlier, help to close that knowledge gap and to tighten the relationships between the various people that are involved in creating these automated decision-making systems.
Great. I'm a big fan of the model card work. It's great to know. Amy, what about you? I guess I just realized both of you are from Google. Maybe you actually have quite some overlap.
Yes, we're both from Google, but Andrew sits more on the research side and I sit a bit more on the infrastructure language side. So I would add just very quickly, like in addition to the model cards that Andrew's team worked on is now being open source through TensorFlow, there are other kind of tool sets really. But taking a step back, what I would say is that what I enjoy about every company's approach to building AI systems is I think it's because of the influence of researchers being involved actually in the productionization of AI, meaning they're either, at companies that are creating AI systems or, there are researchers that are sitting within large companies like Microsoft and Google. I find that there's a real thoughtfulness that's approaching the building of the AI systems. And because of this thoughtfulness, we are coming through with actual analytics and tool sets like model cards, fairness indicators, and like a what if tool, for example, to enable practitioners to start implementing, and just testing whether or not their AI system includes bias. I think what's really fascinating about the machine learning workflow is that because a human is in the loop almost any step of the way, bias can be introduced at any level, right? So from a partnerships perspective, what I'm thinking about is first of all, as I'm building partnerships in the ecosystem, am I working with companies that have an awareness and thoughtfulness approach in terms of understanding and limiting bias in the solutions that they provide? So recently, we've gotten really close with 3 startups in this space. One is called Darwin AI. They do a lot of like explainability and interpretability of models, right? So they're thinking about bias in terms of kind of auditing, and being able to understand what an algorithm said. And then the double click on that is whether or not, the algorithm itself was biased. They actually recently even published a paper on auditing the ImageNet data set, which my understanding is that that data set was frequently used in a number of computer vision tasks. And through their technology and platform, they identified that 40% of the data set was identified as female, males 15 to 29, was like 27% of the data set. So they were just, already understanding and be able to unpack that data set that's being used a lot for computer vision tasks, right, is potentially having bias because they didn't have a representative example. Another company that I work with is called Determined.ai, and they basically enable deep learning, machine learning framework to happen on its platform via like hyperparameter tuning. So what they're starting to dig into, and one of the co-founders of Determined.ai is currently at the machine learning department of CMU. So what they're trying to understand is like unpacking, the overfitting issue that happens within, modeling, and whether or not when you overfit, are you kind of then under tuning something such that, it gives rise to bias in the outcome. And then the last company that I'll speak about is called Labelbox. And they're really focused on attacking bias at the labeling data side of the problem, meaning they're trying to put in kind of flags for anyone using their platform to understand whether or not bias is occurring at the labeling stage. So I think 3 very different companies, they're all kind of very aware again about how ML, bias can occur. And because of that knowledge point, because of sometimes their touch points with researchers, they're able to start implementing that and putting in their workflow. So I appreciate, I guess, looking out how folks are kind of identifying the stop gaps and be able to stop it in the process.
Oh, thanks, Amy. Actually, just a side note about the general QA session. I think the attendees can type questions in the chat window, and there are already some questions coming in. And other attendees can actually also like these questions so that we get some kind of ranking within these questions. And I think what Emily and I discussed earlier was that we are going to do some questions that we prepared for maybe the first 45 minutes, then we are going to go do some QA from the audience. And it would be great if you can like the question that you, or sums up the question that you want to be answered. And one of them actually kind of really connect to the theme that everyone talked about just now. Like Amy was just talking about different roles. For instance, the roles a researcher have been playing in this process, and democratize has been a key issue. And the question that I had in mind was how different entities can, what role different entities can play in the process of developing more fair algorithms. For instance, government, this is a question that Luis Fonseca, I guess I tried my best, answers in the QA window as well. And I guess like I was also personally interested in like, what do you think universities can play or academia can play in general, in addition to the industry? And I guess this time, Ben just unmuted himself, so we can start with Ben. Let's go.
Yeah, I'll respond because one of the projects I'm working on is alongside academia. A group at Carnegie Mellon that was originally at University of Chicago, Data Science for Social Good. And the project is around predictive fairness in criminal justice decisions, right? So if we say there's disparity in certain parts of criminal justice decisions, how do we, one, start to unwind that with machine learning? How can machine learning intervene and create more equity and fairness across decision-making? Again, what does fairness even mean is a big portion of the writing that they did. But then also, how can we apply machine learning to reduce recidivism? And one of the reasons I think academia and academics play a big role in this is they're not interested in creating a model with the most lift for a company, right? A lot of times, I was a consultant in data science before, fairness was not a thing that came up a lot. And that's kind of why I got into the space, because our clients would never ask us, okay, but where's the bias? They would just ask like, how many people can I fire? And that's not the right question, right? That's the worst question probably. But what I appreciate is that, data scientists, and I think there were some comments from Andrew about this before. I'll take it a step further and say like, data scientist is a pretty bad name for a job, because these aren't trained scientists, right? These are a lot of folks who come from different backgrounds who've fallen into this space. And so there's not many data scientists who observe the scientific method, right? And we have people who build machine learning systems, and they don't, have an experience in academic or behavioral science, and how do you design that experiment from the start, right? So we end up with a lot of confirmation bias or overfit projects, because you didn't start from a place of actually designing an experiment that made sense or that was trying to get to the truth versus trying to get to a result. So academia does this in a good way, right? I think in Sendil's class, one of the things that we kind of talked about is sort of the algorithm in a lot of cases doesn't matter. It's how you set up the problem and how do you frame it, and what's the data coming in, how did you structure it? And that's where academia does a really, really good job. And it's really exciting, at least for me in the industry, to see kind of this like grassroots in academia and some researchers at places like Google, Facebook, H2O, kind of coming together to work on these projects that, create things like K-Lime or Shapley or disparate impact analysis, because, it's kind of cannibalistic to our business model in general, right? We're sort of saying like, this is a little more rigorous than we're kind of acting like it is in software sales. So it's really awesome because, academics have nothing to prove to like a corporate entity, which is really, really great that they're coming in from an unbiased perspective, right? And that's where I think they play a really big role to get to like the heart of what we're trying to solve in algorithmic bias.
I mean, I think academia clearly has a huge role to play, but I think as the tools get easier to use and more widely used, awareness of bias and fairness in AI and how you can control for that can't be limited to the academics, right? And so, I mean, I know, like, for example, at my company, every employee has to take training on fairness in AI, right? I mean, whether you're directly doing it or not, but whether you're in marketing or sales or someone who's implementing it for people, that kind of awareness and understanding that fairness isn't something that you sort of add on as an ingredient at the end of the system. It's something that you have to think about when you define the task, when you define the data set, when you train the model, every aspect of it, it's something that you think about. So I think certainly there's a huge role for academia, but I think one of the challenges is how do you take that awareness and that care and translate that into what people are doing who, as you say, are data scientists, but aren't really scientists,
just sorry, I guess like my question maybe buried the kind of another side of that question. We were, especially Ruiz was also interested in kind of the role of government in this process, and maybe potentially, I guess, regulation, maybe what he was hinting at, but I guess we can go on with Andrew, or maybe this time let's go on with Amy Xu, and then Ben and Amy can add back if you have anything else on the government side.
So if I heard that correctly, did you want me to jump in on that
Go ahead.
particular point about?
Yeah, go ahead.
Okay.
Yeah, I guess you have trouble seeing the different items. Yeah, go ahead.
My
Andrew.
apologies again. Yeah, so yes, you mentioned regulation, and I think that that's a very important component to all of this. I am under the strong belief that in order to best ensure that data and AI technologies continue to steer in the ethical direction, it has to be bottom up. And by that I mean we have to look at it from a holistic perspective, because the reality is that, you know, we live in a pluralistic society, right? And even things that we can all come to a consensus on as being quote unquote fair may not even apply or make sense in a completely different context. And so how then do you compete with these different notions of fairness across these different societal cultural norms? And so I don't know, I think a better way to, maybe not a better way, but certainly a method of which we can get involvement from the bottom up, so that it's not just, you know, engineering and data scientists and researchers, but also those that are in the community that are also trying to ensure that these technologies, you know, don't sort of, you know, propagate erasure or, you know, any other form of harm that could arise, you know, whether it's representational harm or allocative harm and stuff like that. So and again, this kind of speaks to why I value transparency and education in this space, and researchers play a pivotal role here too, just as everyone else, in that they can oftentimes serve as the champion voice of those respective communities, and that can help to you know, come to the realization that, for example, maybe these algorithms shouldn't even be used in the context for which, you know, in like the criminal justice system, right? Things like that, where it kind of goes even beyond fairness, and it's just understanding the landscape and coming to the realization that maybe this technology just shouldn't exist in this domain, period. And to come to that consensus, you will need regulation, you will need, you know, elected representatives, you will need people's voices, but you also need the data scientists, the researchers, the engineers, product management, designers especially. All of them should be able to have their take on it, irrespective of like even being an ethicist, because we all have our personal ethics, we all have our personal morals, but we also have organizational ethics and organizational morals, and then we have societal level ethics and societal level or morals, and so all of that has to interplay with one another, and that's where the real challenge is at.
I'll jump in and just add to my original point, like with this, like in the government question. And I wouldn't take this stance on a lot of other topics, but I think regulation is very needed. We did a big paper about like what we see in various like global regulatory or oversight guidances. And the reality is just that machine learning is technology that's being used to make a lot of predictions that materially impact people's lives and the people around them. And a lot of these systems are being built without any expertise in there. And additionally, there's not a good infrastructure of, if a machine learning system so finance has SR 11.7, right? If a model breaks or a model makes predictions haphazardly, there is an accountability. There isn't that right now in a lot of machine learning, where if your model makes a prediction that somebody shouldn't get a loan, and that's kind of like a false negative, who's going to be held accountable? There's not really a system for that. And there's not really any way for a government agency to come in and say, okay, your system has been designed haphazardly. And the problem is that similar to like, nuclear energy or air travel, like there are material people who stand to benefit or have negative effects from these systems. And there's just not a good system in place right now. And there just needs to be a better one. So I would argue that like there are certain countries, like GDPR put a really good framework in place. PDP Singapore is a really good oversight of how to start thinking about regulation machine learning. And the reality is that a lot of the kind of proposed guidance, I like PDPC Singapore a lot, and FTC has guidance in the States. These aren't, things like the right to appeal or the right to explanation or, the right to know if there's a third party system in the mix is not something that will, reduce your top or bottom line by some extreme amount, right? It's just kind of like very basic things that you could implement within an org to like really do some CYA in case like a regulatory authority comes in and says, wow, you have really put on a lot of risk to the people that you supposedly serve. That's my 2 cents.
Cool. Amy, should make sure you have a chance.
Thanks. Yeah, I really appreciate what everyone has said, and I would only add on and think about technology has a very strong role to play in helping regulators understand what we are developing. I think it's a massive failure that it took this long for legislators to understand the digital advertising model. Let's take, for example, right? They should not have understood how digital advertising worked in front of a congressional hearing 3 years ago. We collectively as an industry ought to have built that into our conversations with our regulators to help them understand what we're doing so that they have the opportunity to ask their questions ahead of time, right? I think that regulatory, kind of philosophies are being really driven by the EU currently in this area. And I suspect that they will continue to lead the charge in holding, an industry accountable for what we're developing. And it's really on, technology companies really to bridge the gap and make sure that folks understand what is good, what is not good, and then to have an open conversation about what's allowable versus not.
Great. We have like a lot of fantastic questions, so I guess I just jump to the audience question now. Eric Adam asks, I know you are not lawyers and cannot define what is fair, so it's difficult to personally recommend actions that make models or data that are fair, but most of the discussion so far has been around how to measure bias, which is a great first step. What are some specific ways that you have seen companies take actions to produce more equitable outcomes in their algorithms and data? I guess this is a question towards the specific ways that you or other companies are taking to ensure equitable outcomes.
I could jump in here. So there's some good tools, right? I think, one of the there's 2 things that I really, really like. One is actually a tool that is very heavily used by a Booth alum, Nick Schmidt at BLDS, an economic consulting firm, talking about the Pareto frontier of fairness and accuracy, right? So you can build a system where you have all of these models that you've created, and there's this leaderboard of accuracy, and you can have accuracy on the x-axis, and then on the y-axis you can have average fairness, right? And so you can plot the frontier of all of the models and see that there is a universe of models that perform right where you want them to, that have a certain level of fairness, and then you can sort of decide, okay, what's the trade-off between a more on average fair model versus like the accuracy trade-off, right? And so you can make, given a necessary accuracy level, the most fair choice, right, on average, right? So there's tools like that where you plot the interaction between accuracy and fairness. And then I think there's some really good tools in the adversarial debiasing, adversarial testing, where you can sort of like feed into your model, say like, obviously our first metric is AUC or whatever your accuracy metric is, but then under the condition that, fairness or disparate impact across a certain, age or ethnicity. Like I want the secondary metric to be indexed on for that disparate impact to be fair. So there's this nice adversarial debiasing and testing methods. There's kind of this Pareto frontier of fairness and accuracy. And I think those are two really good steps forward. So I think like fair XGBoost, adversarial models and stuff like that are, I'm at a tech shop, so that's kind of like what we're looking and what we build. But that's from a technology perspective, that's where we start.
Those are awesome. If I may, I like to add one more type of technology into that mix there. And this comes from some of the research work that not just within Google, but collectively within the ML community. And it's this idea of constraint optimization. Now, I'll try to keep this as high level concept as possible, but basically the idea is that all of these machine learning algorithms, they're all optimized to minimize the defined loss function. So, for example, most of these algorithms by default are optimizing for the highest level of accuracy. But the problem there is that it doesn't quite have a nuanced look with respect to performance outcomes. So even if your model, for example, has 95% accuracy, that doesn't mean that everyone represented in the distribution will perform at that level. You'll have some of these disproportionate outcomes where, depending on certain sensitive categories, it could be greater than 95%, or it could be lesser than 95%. The 95% there is just the average. But instead, with this constraint optimization work, which there's a package available in TensorFlow, and this was all done by the research work of Maya Gupta, as well as Andrew Cotter and Hari Krishna. But the way that it works is, instead, you can define upfront how you want your model to be optimized, and you can say, for example, that I want the false positive rates to be equally low for these particular subgroups that are present in the data set and that will likely exist when this model is being pushed into production and running in the real world. And so you can set those parameters up ahead of time so that you can see how well your model will try to achieve that notion of parity, right? And again, that kind of goes back to how does one define fairness, right? But assuming that you get to that point, or assuming that you come to a consensus on what seems reasonable, given the thought exercise of gauging harm and what have you, there are tools now where you can have these expressive notions of optimization that better reflect real world impact, as opposed to just leaning on one particular metric. So constraint optimization, that's another one in that list, alongside with what was brought up just now as sets of tools and technologies that are really helping to have practitioners think more about notions of fairness.
Cool. Amy, I guess, do you have something to add?
Perhaps there's an element of that question, if I interpret it correctly, is just like how maybe companies are really thinking through and catching bias. Right. So I think we've answered on the tool side and the technology side, but I would just say that having sat in TensorFlow for about 18 months and in Google Research for about that time as well, what I've observed is it started really I think the organization understands that it starts with human design and creating teams that are reflective and diverse and come from a lot of different backgrounds. So we've got a really fantastic research team. I think and Andrew, keep me honest here, I think it's being led by Timnit Gebru, right? And
Timnit Gebru and Meg Mitchell.
Right. And so they're coming at it from the representation lens, right? They themselves are really fantastic researchers and scientists, and they're focused in building a team whose mandate it is to understand the role of how bias comes into AI ML and how do you, kind of approach designing, I guess, fair systems. So that's like, I would say, everyone shared the technology side, but from the human capital side, right? If we ourselves are designing these systems a priori, you want to make sure that you're getting the right representation in that design focus meeting on which to have these conversations. And so I'm a little bit over my skis in terms of like discussing like how they do that work. But I, as an observer, see that, we are moving in that direction at Google. It's very important to ensure representation is at the table when we start thinking about these issues.
Cool. I think we have time for maybe 1 or 2 questions. Let's see how this one goes. And I think Emily told me that there's like some wrap up time for audience for Sandal to make some final comments. This question goes back to the regulation question. How do you think about the trade-off between higher transparency, which will allow for greater scrutiny of the algorithms by the public or the regulators, versus the proprietary nature of these algorithms? They need to bring profit for these individual companies.
So my first job was in quantitative finance, or quantitative trading, which the whole business of that is come up with an algorithm that generates alpha and then lock it down under 30 layers of hidden code and make sure nobody ever finds it out. I'll say one of the reasons I fell into data scientists and really appreciated this space is because all of the scientists and research democratizes these things, right? Like you can go get TensorFlow algorithms. You can go get H2O algorithms, right? We open source everything. And so the proprietary nature comment is oftentimes like use case specific, right? The flavors of how you're going to permeate that algorithm or like code in cost functions or design it within a larger system will be based on like the business objective or business problem that you're trying to solve. But if you end up being at a company where you've created a new fair XGBoost algorithm, you're not going to really keep that like private. The flavors of how you deploy it and monetize it is going to be what you keep proprietary, and that'll just be like the data is confidential, right? And so what's great is that these algorithms just get published and shared around and get improved on. So like the innovation curve of AI and machine learning has just been awesome to watch versus coming from finance where no progress is ever made because everything is under lock and key. So that's been one of my favorite parts about this space is that Google, Microsoft, Facebook, and H2O all have like democratization of algorithms and insights as like a core method, core culture piece.
I think recently I heard that there's a startup called like Papers with Code that I think now Facebook acquired. And I think that when I think about the trade-offs, what I really enjoy is that the participants right now are like kind of like self-regulating. Like we don't necessarily need a ton of government pushing us because we have like really good actors at the table with like right motivations and incentives, right? For the most part, I think. And so, for example, with Papers with Code, they've like done a partnership, I think, with Archive, where papers are published and then everyone can have access to at least the data, not the algorithms, right? So it's really to improve like reproducibility amongst researchers. So I think that that would be like a nice trend, right, to continue pushing on in this area, because we can then essentially as a community commit to a standard that says we want to be more transparent with our data sets and our algorithms. And so, it allows for other folks to test it and to see whether or not they have the same results or to start questioning you if there's a bias. And so the community, a community that self-checks in my mind is actually the best kind. And I see that kind of movement currently within this area.
And I don't see how you can really have fairness without having some degree of transparency, right? Because if you don't know what the model's doing, how do you know if it's unbiased, right? So the two go hand in hand. And I think, from my perspective, it's also important for user acceptance, right? If you have a model that you're expecting some human to act on the recommendation that you're giving, if there's no transparency behind that, if you can't explain to them why it's being recommended, they're not going to do it. And it doesn't matter, even if you can prove that the model's good, it can be difficult to have people accept the recommendation if intuitively it doesn't make sense to them. So when we said this was about bias and fairness, I said, hey, transparency has to come into the conversation.
Great. Just a quick follow-up. I think I'm certainly amazed by the openness of the CS community in terms of algorithms. And I remember in our conversation with Sandal, how we make all our lectures public, it just seems unimaginable for economists. But on the data side, I think going back to Ben's point, how do you see the transparency of data? How would that play out in an auditing setting, or maybe for the, I know Google and GDPR has already have some tools in place. Maybe you can also add some comments on that to help the audience understand what's there and what do you want to see in the maybe near future.
I think that data privacy and security is a really big component, right? I've only really tackled this from the machine learning side, and how do you, from a security and privacy perspective, how do you make a machine learning model that you can't kind of game into giving you information about the decision thresholds on certain features, right? So how do you stop your model from being hacked? I think GDPR, so in California, they just voted to increase a new Consumer Protection Act around data privacy. And I think that's a really good first step, right? I think at the end of the day, a lot of the problems in machine learning, the fail cases of where the AI goes wrong, it's not really going wrong. It's the data that was fed into it tells a pretty bad story, right? So there's a world that we need to understand our data better, and understand where historical biases are kind of creeping into the model, and the model's just kind of picking up on that signal. But there's also a big world of how do we lock down consumer rights with respect to data, and I wouldn't even know where to begin with that massive piece of decision making.
Yeah, and to that point, again, I can't emphasize enough the importance of context here, because, as I mentioned earlier, a lot of these incidents that have arisen in the misuse or misclassification of machine learning systems that have disproportionately impacted underrepresented groups stems from the fact that, at least for many of the cases that I've looked into, the data that was used to fit the algorithm, it was a data set that was ill-fitted for its intents and purposes. And without that context, one can't even begin to figure out how to be held accountable, how to remediate, how to mitigate any of this skewness that if left there could increase harm. And so with that said, in addition to data stewardship, data handling, and abiding by these strict but necessary privacy guidelines, there is something that can be done to better contextualize the societal and cultural elements of a data set without necessarily putting an individual that's in that data set at risk. And so I hope that in the near future, there's more conversations around that, so that next time, if a researcher is looking to download a data set, they'll have way more information about whether or not, this data set is useful in the context that they want to continue to explore and pursue whatever it is that they're trying to work on. Done so in a way that at the same time, it doesn't put anyone at harm there. And if anything, that individual then is able to be better able to decide, make a more informed decision as to whether or not to continue to move forward, or if they do so, they'll know exactly where they need to address things. So trying to interject context into metadata there's something that needs to be explored there. But hopefully in the near future, we'll have a more nuanced way of looking at data that doesn't compromise individuals.
Cool. Any final comment from Amy Xu or Amy Streeter? Great, thanks. I thoroughly enjoyed this conversation, many of the interesting, and I think it actually has some references as a researcher in this area that I didn't know. So I think Emily mentioned before that maybe we can collect some of the references and maybe send them to the attendees next after maybe a couple of days. We have 3 minutes left. I guess that's the right amount of time for Sandal to take over and conclude the session. Thank you so much again to the panelists.
Yeah, thanks to everyone. This was really a terrific discussion. I'm not sure I have 3 minutes worth to say anything, but I will just wrap up by just making one comment, which I think is related to the point about how the ML community had independent of fairness, has this sort of openness, and has that's been a strong suit of it. I want to just make a meta comment, which is it's also noteworthy how the fairness literature has been quite open. I think a lot of the comments that have been made have been, oh, we have these models, you can apply these things, Model Cards is open source. And so it's quite satisfying that the fairness tools have gone in an openness direction early in this area. Maybe this area is very young, but early on in the area, there was actually a move more in the direction of like consulting services, which I think is powerful, but led to something that looked like it was going to be much more closed. But I think that is not what's happening. So that's kind of promising. The second comment I'll make is just around, to put this in some temporal perspective, I think it's fair to say research in this area, action in this area has not really much older than 3 years, 4 years max. And if you look at a 4-year horizon, how quickly this area has taken off and how much work has been done and how much work is taking place, I think that should speak to, we should have some optimism about this, because we've kind of very quickly blown through to get to the point where we are now, talking about transparency, talking about, checking models, like what is the right metrics of fairness? And now I think some of the questions like Luisa asked are now like, well, what is the role of government? And on that, let me just conclude with the last thing, which is, I independent of what you believe the role of government is, I just want to make one observation that didn't come up, which is that government is already involved in this. You cannot avoid it, simply because there are regulations in place already, not about algorithms, but about hiring discrimination, about credit score discrimination. These algorithms were written because algorithms didn't start this, people started this. And we had rules for what people could and couldn't do. So there is, I think, the next area, if we've had 4 years of a big run, the next area that people will have to confront is, even if you believe there should be no net new regulation, well, okay, how should I take the regulations that exist for disparate treatment, disparate impact applied to humans? How should they even be applied to algorithms? Is the algorithm like a human? Should it be treated differently? And the reason I'm putting that as a call to action is this is already being decided, and it's being decided right now. New York State is doing some interesting stuff. The Senate has chosen to intervene, step into some of these issues. And I think if the panelists and the people like the panelists don't get involved in those issues, it's not going to be decided in a smart way. It's going to be being decided in some way that's going to have massive ripple effects. So I hope that people start getting involved in those conversations. But this has been a terrific conversation. Thank you all. And I'll just hand it to Emily.
Thank you so much, Sendal, and everyone for participating. I learned a lot today. I scribbled my notes, so hopefully I can make sense of them and send out some references and thoughts for everyone. For the students who attended today, the panelists have all very graciously agreed to be open to communication from you. So please reach out to them on LinkedIn and form a connection. If you'd like to connect with them directly, you can reach out to the center, and I'll connect you with the panelists directly. Thank you everyone again so much for coming and for speaking. I hope you have a wonderful weekend and stay well during this time. Wear your masks, make good decisions, and we'll see you at the next event. Okay, bye-bye.
Thanks so much.
Everyone.
Bye.
I
Thank
hope
you.
you get your power back, Andrew.
Yes.
Yes, I hope so too. Oh dear. Thank you all.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye.